process capability example E. This is our last capability example, and it is a bit odd, so that's why I'm presenting it to you. We're talking about chair weight being between 10 to 11 pounds, and let's go ahead and jump over and take a look at the answers. All right, nothing big here. X bar, bar. Remember, 10 to 11 pounds. And sigma, like I said, is equals to standard dev dot s because it's a sample. It's not the entire. We're not measuring every single part. We're just a sampling of them. And of course, it's going to be of those numbers. Also notice that that little white thing there, that really is part of it. It just doesn't show it's being shaded. See, when I click on it and drag it over, and it doesn't show, but it really is. Just like if I were to start and go down here, see how that one doesn't do it either. So it is included. So anyway, and the CP is going to be 11 minus 10, which is 1, divided by 6 standard deviations. So 6 times this number. So 1.85, pretty good. But the CPK is negative. And you say to yourself, why in the world is it negative? I must have done something wrong. And actually, I did not do something wrong. And we'll explore why that is. All right. I'm going to do the CPK lower. I'm going to do the X bar minus the 10. Ooh, there it is. See that? The X bar, the average, the process average, is actually below the lower specification point. So therefore, it's going to be negative because 9.97 minus 10 is going to be negative. And when you see a negative, it just means the average is outside of the specification limits. Well, if I had a value that was above 11, it would be negative as well. So let's just go ahead and put in. Let's put in 11.2 and watch what happens to these numbers. The CPK would change to 4.45 for the lower, but then negative 0.74 because of this being above that. So that's how that works. Okay, I reverted it back to where it was. All right, so we have negative 0.12 is our CPK value. Very, very poor. It means over half the stuff we're making is bad. Probably more like 60% or 55% is not meeting the specification. Is the process currently capable of producing parts to specifications? Same old question. No, of course not. This is terrible. I just told you about 55 or 60% of the parts are probably not meeting engineering specifications. The CPK is not sufficient at negative 0.12 to meet specifications. The CPK needed to be at least 1.0. Having a CPK of at least 1.33 provides a little more room for process variability. The negative CPK means that the process average is below the LSL, the lower specification limits set by engineering. And of course, remember, like the example I did, if the average was above the upper specification limits, then it would be negative here and therefore negative there as well. All right. If the parts were perfectly centered, would they be capable? Yes. The CP is a measure of how our process would perform if it was perfectly centered in the middle of the specs. I've read that 4 times already. This is my 5th time. In our case, the CP equals 185, which is much more than the needed minimum of 1.0 needed to produce all parts to spec. So I've got my 1.33 comment in here. I could put it in here, or both, but it has to be in one of those two. And the new CP, if I doubled the specifications, like before, I just take the CP and multiply it times 2, 3.70. A very, very, very fine CP value. And if I was going to try to set my specifications using my current data to be a CPK of 1, what I do is I just say x bar minus 1, because that's my desired, times 3 times my standard deviation. Similarly for this one, I would say x bar plus 1 times 3 times standard deviation. And the last one would be, if we're looking for desired CPK of 1.33, then what we end up doing here is we say x bar minus 1.33 times 3 times standard deviations for this one. And for this one, x bar plus 1.33 times 3 times standard deviation. And as I mentioned in an earlier video, if I said to you I want to obtain a CPK of 1.67, then what I would do is I would put in 1.67 there instead of 1.33 or 1.0. So